So this is technically day 3 on factoring, third day on this section 8.5, and today we're going to learn about the zero product property. But before that, we should practice what we learned, which is factoring by grouping. So there's a long 4-term polynomial, and I want you to factor this using the grouping method. And in case you forgot, here are the steps to factoring by grouping. You want to, step 1, separate it into 2 groups. Step 2, factor something out of the first group, factor something out of the second group. Step 3, take a step back and factor the common binomial out. So I want to pause it, you guys go for it, then I want to explain it. We want to emphasize this part right here, common binomial. You need a common binomial. The binomial has to be exactly the same in the first group and the second group in order for you to factor it out. So let's explain this guy. Step 1, separate it into 2 groups. So that's exactly what we're going to do. 12a squared minus 15ab, leave some space, minus 16a plus 20b. And let's factor, step 2, factor something out of the first group. Okay, so what could we pull out of there? A definite 3 and an a, right? A 3 and an a. Okay, now the second group, what could I pull out of there? A negative 4 and a, I guess that's it, just negative 4, right? So now that we know the GCF in the first group and the second group, let's actually pull it out and see what's left over on the inside. This is where you do reverse distributive property. In other words, 3a times what gets you the 12a squared? 4a, right? You need the a squared, so 3a times 4a will get you the 12a squared. How about 3a times what gets you the negative 15ab? Negative 5b. Okay. Now over here, the negative 4 times what gets us negative 16a? Positive 4a. And negative 4 times what gets us a positive 20b? A negative 5 with the b. And now we could see that we have a common binomial in both the first group and the second group, and that's what step 3 is. Take a step back and factor the common binomial out. All right, so I like to exaggerate parentheses, and then we're going to pull out that common binomial out here in the front, and that is a 4a minus 5b, 4a minus 5b. And then what's left over on the inside? The 3a comes down, the minus 4 comes down, and again, I just show the exaggerated parentheses so you could see that that common binomial is missing there and there. Okay, of course, let's write it with the correct size parentheses. 4a minus 5b times 3a minus 4. That is your final answer when you factor by grouping. We will need factoring by grouping throughout chapter 8, the rest of it, right? So it's very important. Let's not forget this. We're going to move on to some easier things, but I do not want you to forget factoring by grouping. Today, we're going to be learning about the zero product property. It's very easy. We already know, in a way, the zero product property. In other words, if I have 3 times a certain number, I'm not going to tell you, but if the answer is 0, what does that number have to be? 0. It has to be 0, right? See, the word zero product property, property is like the truth, right? A fact in math, a truth in math. Product means multiply. 0 is when you get the answer 0. So when you're multiplying 2 terms and the answer is 0, well, your first term could be 0, or your second term could be 0, or maybe both are 0. And that's what zero product property is all about. Let's take a look at our notes, everybody, to the final section that we haven't done yet, way down here. Let me get this out of the way to make more space. So down here, it says a zero product property. And it tells us if you have a number times another number and it equals 0, it doesn't have to be numbers, it could be variables. If 2 things multiply together give you 0, then the first something could be 0 or the second something could be 0. Or maybe both, right? But one of them or both have to be 0. So whenever you're multiplying 2 items and you get 0, you know that the first item could be 0 or the second item could be 0. So why is zero product property important? Because it helps us solve quadratic equations. See, we've been solving equations, but if we look at number 2 right here, and I say solve it, what you guys know is to get x by itself. But the problem is you have two different types of x's. You have an x and you have an x squared. So how are you going to get it by itself? You can't even combine them because they're not like terms, right? But we do know, or we just learned about zero product property, and what that says is that if you have two items being multiplied together, and right here we do have a binomial times a binomial, and the answer is 0, what zero product property allows us to do, it allows us to take this complicated looking equation and create two simple equations, all right? So the first something, this x minus 9, that could be 0. So let's write that down. X minus 9 could be 0. And the second something, the 2x plus 1, that could also be 0. So let's write that down. 2x plus 1 could also be 0. This is applying the zero product property. What did I just do? I recognized, hey, I have something times something, and the answer is 0. The zero product property allows me to separate them and create two simple equations, each set equal to 0. Now, all I have to do is solve the first one. Plus 9, my answer is x equals 9. Solve the second one, minus 1, 2x equals minus 1. So you're going to divide by 2, and x will equal negative 1/2. That's the other answer. So now we actually get two different answers for equations. Before it was like solve it, oh, x equals 5, x equals 9. This time, x equals 9 and x equals negative 1/2. It actually has two answers. If you were to plug in 9 right here and right there, it would work out and give you 0. Or if you were to plug in negative 1/2 right here and right here, it will give you 0 when you work it all out. So the zero product property, what it allows you to do is take a complicated looking equation and create two simple equations. If you have a times b equals 0, then a could be equal to 0 and b could be equal to 0. Those are your two simple equations. Over here on number 2, I cannot apply the zero product property yet. Why? Because I am not multiplying two things to give me 0. I'm actually adding. That doesn't make sense. I need zero product property. I need it to be multiplication. So if I have addition and I want multiplication, how could I do that? I am going to factor, right? Factoring is reverse distributive property. Factoring is like if you had the answer and you want the multiplication problem that gave you that answer. So I'm going to factor what's in common, the GCF, in these two terms. In other words, I'm temporarily going to ignore the right side of the equation. I'm just going to look at the left side, and I'm going to pull out the GCF. What's the GCF? X. So I could pull out an x. Everybody follow along, please. If I pull out an x, what's left over on the inside? X plus 4. Perfect. All right. So what do I have here, guys? I have a factored form. Whoops. I have a factored form equation. So in other words, the left side's now factored. I still have it equal to 0, and now I could actually apply the zero product property. Why is that? Because I really do have something times something else gives me 0. I have an x times a binomial, x plus 4 equal to 0. And the zero product property says whenever you're multiplying two terms and they equal to 0, you could separate them and set each equal to 0. So you're going to put x, that could equal 0, and you're going to put x plus 4, that could equal 0. Again, the zero product property allows you to take a complicated looking equation and you create two simple equations. And the only time you could actually apply the zero product property is if it equals 0. If it doesn't equal 0, you can't split it. If you had a 1 right here, you can't split them and say that each of them equal to 1. It doesn't work, right? It's the zero product property, not the 1 product property or the 3 product property. It is the zero product property. You need it to be equal to 0. You need two things being multiplied together. That way you could split them and set them each equal to 0. Anyways, that's only half the battle. You still need to solve them. And this one's already solved for you. There's nothing to do there. But the other one, you're going to subtract 4, x will equal negative 4. Are you with me? Nice and easy, right? Let's look at number 3. So number 3, it's already in factored form. It would be ridiculous for you to distribute. That would be incorrect. I mean, normally step 1 of solving an equation is to simplify. But right now that you know the zero product property, you should see that you have something times something else, and it equals 0, and you have to split that, both terms, and set them each equal to 0. So I see that I have something times something, and it equals 0. So I'm going to set them each equal to 0. That first something could be 0. The second something could be 0. So my answers are x equals 0, because there's nothing to do right there on that first equation. And the second equation is what? What's the answer? Negative 12. You subtract 12 on both sides. x equals negative 12. So those are your two answers for this equation on number 3. Okay. Now I know that you could look at the original equation and you could do all this in your head, but I do want you to show your work on the homework today. That way we could practice what zero product property is, which is splitting a complicated looking equation into two easier equations by setting them each equal to 0, each part equal to 0. Let's take a look at our homework from the past couple of days. The first part of the homework was factoring out the GCF. That was 1 through 12. And then we got to number 13. That was where we had to factor by grouping, right? And then we have the backside. Let's turn to the backside. On the backside, it says solve each equation, all right? And now that we know zero product property, we are able to solve each equation. Now, it would be, again, ridiculous for you to get to number 19 and then start distributing, even though that's probably your first reaction when you see something like that. But don't distribute. Why not? Because we know something. We know zero product property. And zero product property says when you have something times something else and the answer is 0, you could split it and set each of them equal to 0. So let's do that. The x could be 0. And the x minus 32 could also be 0. So let's solve both of them. This one's already solved for us. This one's going to be plus 32 plus 32. Your answer is x equals 32. And those are your two answers to number 19. So all of these, 19, 20, 21, all the way to 24, they're all done the same way. They're all already factored for you, right? They're all factored for you. Let's take a look at number 24. What am I going to do here? Since it's already something times something equals 0, what do? The zero product property allows you to take the first something, set it equal to 0, take the second something and set it equal to 0. So let's write it out. 4y plus 8 equals 0. And let's write it out. 3y minus 4 equals 0. Let's solve the first simple equation. So that's going to be a minus 8. Minus 8. We're going to have 4y equals negative 8. We're going to divide by 4. Divide by 4. Final answer is y equals negative 2. That's one answer for number 24. Let's do the other simple equation by adding 4, right? This is like two separate problems. Cancels. We're going to end up with 3y equals 4. My final step would be to divide by 3, divide by 3. Final answer is y equals 4/3. So you get two answers for number 24. So all of these are really simple. Why? Because your complicated looking equation, you just split them and set them each equal to 0. If they're in factored form, it's really easy. What do you guys notice that's different between the first half, 19 through 24, and the second half, 25 through 30? Exactly. 25 through 30 are not factored. And some of them are not even set equal to 0. Like 27 is not equal to 0. 29, 30 not equal to 0. So let's go with number 25. It's not in factored form. We don't have any parentheses there. So the question is, what could I factor out of number 25? Not only a z, but what? What's your GCF? 2 and a z. 2 and a z. What would be left over on the inside if I pull out a 2z? A z plus 10. Now, why would I factor? Because now I have something times something, and it's still equal to 0. Again, if I didn't have equal to 0, I wouldn't be able to do the zero product property. But because I have equal to 0, I factor it to get multiplication, and now I'm going to split it and set them each equal to 0. So the 2z, that could be equal to 0. And also this z plus 10, that can also be equal to 0. So my two answers will be divide by 2, z equals 0. And then over here, minus 10, z equals negative 10. Those are my two answers for number 25. So again, the zero product property is all about having multiplication between two terms that's equal to 0, That way you could take those two terms and split them and set them each equal to 0. And then you solve both of them and you get your two answers. So what if you didn't have it equal to 0? Like let's say number 30. Number 30 is not equal to 0. What the heck could I do there? If it's not equal to 0, make it equal 0. Right? In other words, if you want a 0 right here, you don't want this negative 26x, what could he do? How could you get rid of a minus 26x? Plus 26x. And what you do to one side, you do to the other side. Now, could we actually add x squares and x's?
Yes.
No.
Why not?
They're not like terms, right?
Oh, 'cause it's that.
So I can't really say, oh, a plus 26 is 34. You're just going to rewrite it, put it to the side exactly. So let's rewrite it. You're going to have an 8x squared plus 26x. And now on the right side of the equal sign, it really is 0 because those guys canceled out. So now we have an equation that's set equal to 0. And now we could start thinking about zero product property. But then again, you need it to be multiplication, not addition. So I'm going to factor the left side of my equal sign, the left side of my equation. So what is the GCF to the left side of that equation? 8? No. 4? No. 2. Okay, is that the GCF though? Is it just 2? That's it. Yeah, 2's in common in the numbers, but there's also x's, right? So the GCF really is 2 and an x. Now what's left over if I pull out that 2x? 4x plus 13. So I took my equation and I split it, and I'm going to get 2x, that could equal 0, and 4x plus 13, that could also equal 0. And then I solve both. Divide by 2, divide by 2, x is equal to 0, that's one answer. Minus 13, minus 13. I'm going to end up with 4x equaling negative 13. That didn't work out that nice, but that's okay. Divide by 4, and your other answer will be negative 13 over 4. It's okay to get fractions as answers. So your two answers are x equals 0, that's one answer, and x equals negative 13 over 4. I guess you could write that as a mixed number. That could be negative 3 and 1/4. But I believe on your answers, on the back of your notes that I handed out a couple of days ago, it left it as an improper fraction, negative 13 over 4. So that's how you do the rest of your homework. We've spent 3 days on one worksheet, guys. It's two-sided, but you guys need to finish up every single question on this, all right? So go back and do these easy questions on the back side. If you haven't done the front side of the worksheet, you haven't done the pulling out the GCF, please do that. You haven't done factoring by grouping, please do that. You need to have everything complete.